Welcome everybody, this is Mr. Ndabezeta, and this time I think we should look at mathematics. So I am confronted with a question paper before me on the screen here. It's at Tshwane University of Technology, and this question assignment was provided on October 2023. This is the second class test, so this was given as an assignment, unfortunately, and you had to have your student number, the name and the initials. This is the Department of Mathematics and Statistics, the subject Mathematics and Stats, code MST 105X, and the due date was on the 17th of October 2023, and it's worth 20 marks. So I'm doing this tutorial on behalf of an individual who means so much to me. She's the mother of my child. She's an animal scientist. Okay, so the first most important thing that I think we should look at, it's in question 1. It's a total of 14 marks. So in question 1, they say consider the following functions: f at x equals x plus 2 and g at x equals 4 minus x squared. So the first thing that we need to do is to try and analyze what these functions are. So the first one, f at x equals x plus 2, it's a straight line. It is defined by the mathematical equation y equals mx plus c. And the second one, it's a parabola, and this one it's defined by the mathematical equation f at x equals ax squared plus b, where b it's shifting the graph a certain units upwards or downwards. And when the coefficient of x squared is negative, we know that the graph will frown. The graph will look something like this, and it will be translated for units upwards. So having that information gives us an insight view as to what we are dealing with. So we are dealing with a parabola as a g at x and a straight line as the f at x. And then in question 1.1, they say determine f the inverse. Whenever you see that minus 1 there is a superscript, this is an inverse, and g the inverse, and this is equated for 4 marks. So what I'm going to do, I'm going to draw your attention into this slide that I have in here. Well, this is the solution that I have provided for the lady. So we have f at x and g at x. We have both defined these functions, and we are looking for the inverse of f and the inverse of g. So the very first thing that we need to do is to write down that which is provided to us. You write first f at x equals x plus 2, just as it is there. So what is it that we know whenever you want to write the inverse of a function that is provided? The first thing that we need to know, right, we know that f at x is the same as y. So in the place of f at x, I have written y, and I still have this on the side. So y equals x plus 2. So once you have done that, you have to interchange x and y. You swap them. Where you see y, you write x, and where you see x, you write y. This is very, very important. So this is the first thing that you do whenever you want to write an inverse of a function. So you interchange x and y. So where you see y, you write x, and where you see x, you write y, and you have your plus 2. Okay, and then you want to make y the subject of the formula, because you have to write it as y equals something, just as it was written here. So here we want to make y the subject of the formula. Already on this side we have x, so we leave x as it is. We have the equal sign. Then we have y on this side. We want to make y the subject of the formula. You take this positive 2, you take it to the other side of the equal sign, and when this 2 goes to the other side of the equal sign, it becomes negative. If any value or any alphabet that goes to the other side of the equal sign, if it was positive, on the other side it becomes negative. So on this side we are left with y, which is equals to x minus 2. So what is this? This is the inverse of that function. and you just conclude here to say, remember, this is y, the inverse of x, the inverse of y, it's equals to x minus 2. So this is just us concluding here. And one most important thing that we need to learn from here is that the inverse of a straight line, it's also a straight line. So when you have a function as a straight line and you want to find the inverse of that straight line, it is going to be the inverse. Sorry, it is also going to be a straight line. So the inverse of a straight line is a straight line. But the difference between the two, the y-intercept is 2 here and the y-intercept is minus 2 in this one. So whenever we have time, we will draw the inverses of these functions so that you may see the differences. I will also show you a tabular form where we interchange x and y and we draw the inverse of those functions. But for this tutorial, this will not be happening. So this is just the inverse of f. We haven't done the inverse of g. We were just discussing the inverse of f. Be that as it may, we can go to g at x, which is equals to 4 minus x squared, the original function that is provided to us, and we write that exactly as it is. But we know that g at x is y, so I'm just writing y equals 4 minus x squared, and as you can see here, I'm not changing anything. When we get here, what is it that I'm doing? I am interchanging x and y. Where I see y, I'm writing x, and where I see x, I'm writing y. So remember, this is x squared, this will be y squared. Very important. And then from there, I need to make y the subject of the formula. Please do not forget it. So this doesn't have y, it will go to that side. So on this side, you already have x. When this goes to that side, because it is positive, it becomes negative. So you have x minus 4 equals this one, it's negative. Please be very careful there. Minus y squared. There it is. But we know that the coefficient of y squared has to be positive, so I will multiply both left and right with minus 1, because the value, the coefficient of y squared there, it's 1. There's a 1 here. There's a 1 that we don't write, but you should always know that it is there. So I will multiply both left and right by minus 1. So this was just to denote that this negative is going to multiply everything that is here. So I just decided to enter them inside of a bracket so that you know that BODMAS has to be applied whenever you remove the brackets by multiplication. And this is exactly what I did on the second step. Negative times x, it's negative x, and negative times negative is a positive 4, that is equals to y squared. Then from there I make I have my y squared equals minus x plus 4. I want the value of y, not y squared. So in order to get rid of the superscript 2 here, you have to square both sides. And this is exactly what I have done. So when you square both sides, the 2 and the square root goes once into each other, and you are only left with y, and this y is equals to what you have on the left hand side, which is the square root of x plus 4. Very important stuff. So g inverse of x is equals to what? Remember, this is negative, this is minus x, so you have minus x plus 4. Remember, there it is, minus x plus 4. So g, the inverse of x, is equals to minus x plus 4. So this is very, very important that we understand what is happening there. Very, very important. So this is just question 1.1, and I just hope that we have understood what is happening here. Very, very important that we see that. So we go to 1.2, and they are looking for, I think there was just an error typing there. This composite function should have been between the inverse of f and the inverse of g. This O normally comes in between those two inverses. So I assumed that it should be there. I don't know whether this is the intention, but I assume that it should have been somewhere there. So when I solved it by the assumption that this O is between the inverse of F and the inverse of G. And let me just take you very quickly through the slide, and this is where we are. Okay, let me just try to zoom so that we may see what is happening here. So in 1.2, they are looking for the composite of the inverse of F and the inverse of G. And what does that really mean? It simply means that the composite function in this case tells us that go and do what? Go and define the inverse of G inside the inverse of F. So the first thing that I did, let's write down the inverses that we have just calculated in 1.2. We found the inverse of F as x minus 2, and then this is the O, the composite sign, and let's write down the inverse of G, which is the square root of minus x plus 4. And then from here, let's now find the composite. What does that mean? Go and define the inverse of G inside of F. What does that mean, Mike? Where we see x in the inverse of F, you will be writing the square root of minus x plus 4. This is very important. Where you see x in this function, for this function, because we are defining this function inside of that function, we are saying take this function, whatever that you have, minus x plus 4, write the square root of minus x plus 4 where you see x in this inverse of F. So the inverse of F is x minus 2. So in this where I see x, I'm going to write the square root of minus x plus 4. And here it is. I wrote down first the inverse of F, which is x minus 2, and then I demonstrated here that where I see x, I substituted with the square root of minus x plus 4 minus 2. So please be careful, this minus 2 has to be outside because the square root is in here, not entirely in this. Very important. So we will just say the square root of minus x plus 4 minus 2, that is outside, because these two things are separate and they are separated by a minus. So you have to separate this with that by the very same minus. Very, very important. So F, the inverse composite of G, the inverse defining the inverse of G inside the inverse of F, is therefore the equivalency of the square root of minus x plus 4 minus 2. And you would have solved the problem. Okay, remember I assumed. Let us continue in this. Then in 1.3, they say determine G equals x plus 2. I decided to play a lot with that, just to see whether students do understand what is happening there. So I want to share with you something. They say to us that we should determine G is equals to x plus 2. What does that mean? We are given G at x, which is equals to 4 minus x squared, and this is a function. G at x is a function. Why is it a function? Because it is the relationship that exists between the values of x and the values of y that will end you up with a coordinate system. Because when you substitute the values of x here, you will find a corresponding value of y. So there's a function that is happening, a one-to-one function, the value of x mapping to exactly one value of y. But here, G is equals to x plus 2. First of all, this is not a function, because if it was a function, we could have something like G at P or G at something, just as we have here G at X. Then we would know that it is a function. So it is not a function. There has to be a substitution that is happening where in G here. But the question is, how do we do that? Will it be correct? Please listen very carefully. Will it be correct since we have g at x equals 4 minus x squared? Is it possible that in this function where we see g, we will be writing x plus 2 and then leaving that x just as I did here? This is just a question I'm asking you and saying that this is equals to 4 minus x squared. And then from there, knowing that this is a difference of two squares, will it be possible if I divide both sides by x plus 2 such that this is the numerator and the denominator, they go once into each other and I'm left with x, and I'm removing the brackets because there's no longer multiplication taking place here, and I'm saying that x is equals to, and I factorize this. Now, how did I factorize this? I made two brackets. I know that 4 is a perfect square. The square root of 4 is 2. So you write 2 here and you write 2 there. Alright? And then once that is done, the second thing that I do, you have x squared because it's a perfect square. The square root of x squared is x. I write 1x and 1x there. Now what is the difference of two squares? The other bracket, it's positive, separated by a positive with exactly the same identical things, and this one is separated by a negative. This is what we call the difference of two squares. So I made difference of two squares and I divided by x plus 2 because I did that on the left. It also has to be applied on the right, and this into this they will cancel because this is the same as x plus 2. And then when they cancel, your x is equals to 2 minus x. We are not done here. We can take this one to the other side because they are like terms. X plus x equals 2, 2x equals 2, and x equals 1. Is this a possibility? This is the question that I ask myself. And then we say g is equals to x plus 2, and we have x as 1. 1 plus 2 equals to 3. So is it possible that g equals x plus 2 will give you 3, or we just leave it as x being equals to 1? So this is something that I want you to sit down and ponder on. Just leave some comments on this, just to tell me your ideas as to whether this is correct or not. And then once we have discussed this, and then I will sit down, make a tutorial trying to explain to you exactly what is happening here. I left this in this way for somebody who might be thinking in this manner, and if this is the way in which you think, please tell me why. Okay, I will leave you with that. So this is just 1.3 and it's just 2 marks for that. Right, and we have 1.4. They say plot the graph of g at x and g at x plus 2 on the same axis. Okay, let me check if I have solved that problem. Okay, sorry, this is 1.3. Let's check on 1.4. Here it is. All right, I think I need to rotate this. Even if I can try to rotate, it will not do me any good, but I think I can do this. All right, I'm trying to zoom, but as you can see, as we try to zoom more and more, we are losing something very important. It's becoming very blurry and we just cannot see. We just cannot see. I think I should have taken a much better picture on this, but I don't know what to do. Okay, let me just take a much more better picture on this so that I can explain exactly what is happening. So let me just have a pause here. Okay, we can continue in what we have been doing. Remember, we are in 1.4. They said that we should graph the graph of g at x and that of g at x plus 2. So we we will try to do exactly that. So what I'm going to do here is to take you through the solution of this. So the first thing that I did was to write down the equation of g at x, which is 4 minus x squared, and here try to show you what g at x plus 2 mean. Remember, we have already discussed this. This tells you that in here where you see x, go and write x plus 2. So please, this is not an inverse. We are saying g at x plus 2. We are saying take the value of x plus 2 and write that where you see x. So I have 4 minus, because this is a squared, I have repeated x plus 2 times in the place where I see x, and I still have this negative. And then I have my 4 minus, and then before I multiply by negative, I have to solve the brackets. And here it is, x times x is x squared, x times 2 is positive 2, 2 times x is positive 2x, and 2 times 2 is 4. And then I simplify what I have inside of the brackets. 2x plus 2x is 4x plus 4. So I cannot add any of these terms here. The exponent is 2, the exponent is 1, and it doesn't have an x, so I cannot add the 2. And then removing by multiplication, negative times x squared is negative x squared, negative times 4x, negative 4x, and negative times positive 4, it's negative 4. And this is what I have. Alright, so my g at x plus 2 is what? Is x squared minus 4x, because this is a positive 4 and a negative 4. They will cancel each other and you are left with minus x squared minus 4x. I wanted to simplify this before we can draw the graphs so that you see exactly what is happening. So we have g at x plus 2, which is minus x squared minus 4. And what is this? This is also a parabola. Very important. And I have my g at x equals 4 minus x squared, because they said I should draw the graph of g at x and that of g at x plus 2. Very good. Now, the first thing whenever I have to draw a graph is to always find the x and the y intercepts. So this is the very first thing that I know that I have to do. So the question is, how do we do that? Now I have demonstrated a solution for you up there so that you may be in tune with what I am doing. So let me just place things in a nice setting so that we can explain this. So here we are, and we have our g at x. Okay, let me just increase the brightness of the computer so that we may see things in a more brighter way. So let's just change the brightness so that things may be very bright for us. Okay, here we are, a little bit brighter. That's fine. The recording is still going on. So this is what we have dealt with. Okay, that's fine. And where am I? I am here. So the first thing whenever we draw the graph of any function is to find the x and the y intercept. So this is the dual intercept method. So for x intercept, we know that y has to be 0. For both mathematical literacy student and for pure maths or technical maths, we all know this. This is not something new. So I will use the dual intercept method. For x-intercept, y equals 0. So that is to say, and I'm starting first with this one, this function. That is to say, in this function, where you see y, go and write 0. We know that this is 0. So we have 0 equals 4 minus x squared. Very good. Now we want to make x the subject of the formula. So we take minus x squared to the other side. It becomes positive, and on this side we are left with 4. We want to get rid of x squared because we want the value of x, not the value of x squared. Therefore, I will square both sides. So when I square both sides, 2 and the square root goes once into each other. You are left with x. Remember, when you introduce the square root, you always get 2 solutions. a positive and a negative. So you'll get a 2 here, but remember to say plus or minus 2. So when x is 2, remember you said y is 0, there it is. And also when x is minus 2, y is 0. Very important that you understand that. Alright, now we have the x-intercept. What we need to do is to find the y-intercept. So I'm solving on this side. So y-intercept x equals 0. So where we see x, we write 0. There we are, 4 minus into 0 squared, which is 4. So the coordinate there, when x is 0, y is 4. Always when you give the coordinates, you have to say x first and y after. So these are the coordinates that we have. Alright, when we are done with x and y intercepts, because it's a parabola, we need to go and find the turning points or the stationary points of your graphical representation. So we have g at x equals 4 minus x squared. In order to find the stationary point or the turning point of x, the x value of the turning point, you use the equation minus b over 2a. Now remember, a parabola, it's a graph that is defined by the mathematical equation ax squared plus bx plus c. So the coefficient, the value of x squared, it's what we call a, and the value, the coefficient of x is what we call b, and you have a constant, a value that doesn't have any alphabet. So I tried to rewrite this. I tried to rewrite this in this fashion. We start first with x squared, so it is negative x squared, there it is. Then we write bx. Unfortunately, I don't have a bx, so I'll write 0x plus, and then I write a constant which is a positive 4. There it is. So that when we come here, we understand what is happening. The turning point of x equals minus b over 2a. That would be minus into what is your b? It's 0 divided by 2, and your a is minus 1. And this will give you a 0. Alright, let me just continue in this. Let me see which slide we should work on. Let me see. Okay, this is not the one. Let me go to this one. No. Let me check the slide that I'm looking for. Oh, this is not the slide. Where am I? Okay, no, we have been here. We calculated the turning point of x and found that to be 0. We need to find the corresponding y value. Oh, living God, where is it now? Okay, let me just do this. I think it is in here. Alright, that's fine. Let me just try to bring it a little bit closer. We are losing. Alright, here we are. So once we have calculated the very first turning point of x and we found that to be 0, the second thing we need to do, you take that x coordinate and you substitute it on the original function which you have used, which is g at x equals 4 minus x squared. So that is exactly what we did there. So what we did here was just to take the value of x that we have found and you substitute it here on this equation, g at x equals 4 minus x squared, on the equation that you are currently working on. So where you see x, you'll be writing 0. So 4 minus into 0 squared is 4. So the graph turns where x is 0 and y is 4. So you are done. You should be ready to draw the graph because you need x-intercept, y-intercept, and the stationary point. Right, that was just for g at x. We need to cater also for g at x plus 2. Now remember, g at x plus 2, we found it to be minus x squared minus 4x plus 0 because we don't have a constant. So when we are there, let me look for something a little bit more brighter, something that we can work on, something that can help us in this. I don't know what is happening because I try to take something that was a little bit more brighter, but yes, I think here it is. Yeah, here it is. All right, so here we are. So we had g at x plus 2 equals minus x squared minus 4x plus 0. For x-intercept, y equals to 0. So y equals minus x squared minus 4x plus 0. And then remember, for y-intercept, for x-intercept, your y has to be 0. So 0 equals minus x squared minus 4x. Good. And then we make x the subject of the formula. We took this one to the other side. It becomes positive. X squared equals minus 4x. This is what is left on this side. And then I can divide both sides by x. And then I have x squared and x. When I divide, I have two of them. I have only one. The exponent is 1 on this one. When I cancel 1 on numerator and denominator, I'm left with 1x on the numerator. That is equals this, and this will cancel each other, and I'm left with minus 4. So the x coordinate, the x point or the x value of the turning point is minus 4. And we know how to find the corresponding y value. We just substitute this minus 4 on the original equation here. So when we do that, what do we get? Well, it looks like I have done a very serious mistake here. You see what I did? I substituted 0 here, and we never found the value of x as 0. So let me just quickly solve that. So let me just quickly try to solve that. And this is going to cause us a lot. This is going to cause us a lot. Okay, let me just come here. And I have a calculator somewhere around here. There it is. So I have made a very serious mistake there. We should have substituted with a value of minus 4. So let me just quickly fix that. The value should have been minus 4. So I could have said minus, remember we are substituting here, minus into minus 4. That is a squared minus 4 into minus 4. This is exactly what I should have done. I'm very sorry, I don't know what confused me there to substitute with a 0, because the value of x was never a 0 there. So okay, but it's fine now that I recognize what is happening. I wasn't paying attention maybe. So let's find out what the value would be. Oh, we are still correct. The value is 0. The value is 0, so the graph is going to correspond very much with what we did, but I shouldn't have substituted as 0 here. Very important. I should have substituted a value of minus 4. My apologies. Okay, and then we now have the x-intercept. We have the y. What is happening here, guys? Okay, we had the turning point. There it is. And then we found, oh guys, I'm sorry. I thought we are calculating the y coordinate of the turning point. I'm very sorry, we already did that here. I'm very sorry. 0 and minus 4, we were calculating the y intercept here. I'm very sorry. I this is embarrassing. I'm very sorry. Y-intercept x equals to 0. So where we see x, we substitute with 0. So y into 0 is equals to minus x squared minus 4x. This is just to say where we see x, we will be writing 0. And we find out it to be 0. So when x is 0, y is also 0. I'm very sorry with this lot of nonsense. I'm very sorry, guys. There's a lot happening. There's truly a lot. All right. Once we have the x and y intercept, we have also the turning points, which is this. Now we can be able to draw the graph that is required from us. And let me just go to the folder where everything is set, and I think I have the graphical representation done for us here. So I tried to copy down the values. We have x-intercepts, there they are, remember, and the y-intercept was found to be 4. And then we can now begin to draw the graph for the first one, remember, for g at x. And we found that to be, remember, this is the graph of x squared plus 4. So what is it that we did? When x is 2, y is 0, there it is, the first point. When x is minus 2, y is 0, there it is, the second point. And the graph has a y-intercept. When x is 0, y is 4, there it is. And it turns at the very same point where it has the y-intercept. So y-intercept, we have 4 as the y-intercept and also as the turning point. So it has a y-intercept which is also a turning point. So this is the shape of the graph. On the other side, we have these values. When x is minus 4, y is 0, we have the y-intercept of 0 and 0 and the turning point of minus 2 and 4. So when x is minus 4, y is 0, there it is. And when x is 0, y is also 0, there it is. And when x is minus 2, y is 4. When x is minus 2, y is 4. And we have a shape like this. There it is. And then we are done with that. So we are done with 1.4 and we go to 1.5. What is the relationship between the graph of g at x and the graph of g at x plus 2? This is the graph. The graph of g at x plus 2 is the graph of g at x shifted 2 units to the left. So let me just go and check. Here we are. We can investigate this, check what is happening. The graph of g, there it is, remember, and the graph of g at x plus 2, there it is. Now let's check this point. It was at 2. On g at x plus 2, it's at 0, so it is shifted 2 units because it's 1, 2. And then let's check this one. The point here is minus 2 and the point there is minus 4. So it has moved minus 3, minus 4. So hence we are saying the graph of g at x plus 2 is the graph of g at x shifted 2 units to the left. And then we should be fine in just answering that question. And then we go to question 2. Solve for x, give the answer correctly to 4 decimal places where necessary. And I have assumed for the second time. I thought the lecture here wanted to say 2 base 3, log 2 base 3. So I assumed the lecture wanted to say that. I just assumed here. And now this is what I did. Let me just close up these ones. And let me take you through my folder. Where is 2.1? Oh, this is 2.2. 2.1 should be somewhere here. And there it is. So let me just zoom in. So I assumed that this is log 2 base 3. So we have log 2 base x minus 2 minus 1 equals log 2 base 3. That's fine. So what I did here, I wrote this as it is, and I know that 1 can also be written as log 2 base 2. I know the answer here is 1. So I'm trying to introduce logs on all of them, and the base should always be 2. Very important. So this is what I have. I changed this to this because it's a 1, and I have that on the right hand side. So secondly, I took this one to the other side. There it is positive, it becomes negative. And I know the law of logs says that when you subtract, you divide. So what I did, I wrote log 2, there it is, and then you take the bases and you divide them. So you have x minus 2, you divide it by base 3, you divide it by base 2, and you divide also by base 3, because they are all in subtraction. When you subtract, you divide. So here we are, log 2. Look, you have log 2, and log 2. So you'll just say x minus 2 divided by 2 divided by 3. This is what I have, and this is equals to 0. Because this is an equation, when you take this to the other side, you are left with a 0. And then when we are here, I just change division to multiplication, and then they become the reciprocals of one another. So what I did there was just to change division to multiplication. At the very same time, I changed the logarithmic to exponential. So what you do, it's like the log just disappears, and you say 2 this base raised to the exponent of what is on the other side of the equal sign. There it is, and it will be equals to whatever that you have on the brackets. Here it is. And you see that I have x minus 2 divided by 2. There it is. And what I did here was to change division to multiplication, and when you do that, you will have the reciprocals. The denominator becomes the numerator, and the numerator becomes the denominator. And when that is fine, any number to exponent 0, the answer is 1. And then when you multiply here, you have x minus 2 times 1, which is exactly that. 2 times 3 is 6. And then because you have equal sign, you can cross multiply. 6 times 1 is 6. This is equals to x minus 2. Take this to the other side, and your x is 8. And we can investigate this. We can just try to investigate that. Let's go to a calculator once again. And let me just try to open up the calculator once again. And let me just open up the slide. So what we can do, we can even take it just from here. I can say log 2. And I can say the value of x, remember we found it to be 8. So what I can do is to just say 8 minus 2. Very good. Go outside and subtract the log of 2 base 2. And go and subtract the log of 2 base 3, and try to find out what you will have. Exactly 0. So this verifies that what we did is correct. So that was 2.1. We had to find that for 3 marks, and we are left with the very last problem, which is 2.3. And I think 2.3 might be just somewhere here. So we dealt with 2.1. Now we are on 2.2. And let's check whether I'm following correctly. Yes, that is true. This is what we have. Let me just zoom in for you. This is exactly what we have for 3 marks. So we can come here, try to zoom in as we solve. So 3 plus e 2x plus 1 equals 7. This and this are like terms. We took this to the other side. It changes the sign. 7 minus 3, it's 4. So I want to get rid of e. You introduce the ln on both sides. Ln of this equals the ln on 4. Ln and e is 1. You are left with 2x plus 1, which is ln 4. And then you take 1 to the other side. 2x equals ln 4 minus 1. You divide both sides by 2 and you get 0.1932. And we can investigate because they said to 4 decimal places. We can see if that is true. 3 plus second function, and we go to e. Where is the e? The e, there it is. Delete, shift. Okay, sorry. All right, how do we do that? Are we not supposed to say shift and we say e? Or what is it that we need to do? Alpha e. Oh, there it is. And to the exponent of 2, our 0.1932. And let's see whether this will be equals to 7. 3 plus e. Oh, I forgot to say plus 1. So let's just come here. In fact, it has to be outside because this is a multiplication, and then we just have to say plus 1, and the value is exactly 7. Remember, we rounded off here, so we cannot find exactly the value as 7 as a whole number because we rounded off to 4 decimal places. But this is just basically what we had to do, and I will assume that you guys have understood what is happening here. Thanks for watching. This was for somebody very important, and I will see you in the next tutorial.